This is the video for written homework 4 for heat and mass. This first problem had to deal with finding a heat transfer variable, but what you had to go through in order to find it was work through a pipe with an inner and outer diameter and different fin lengths around it. And in order to do so, you had to use all these equations, and of sort, you had to use radius or critical radii, and you had to use the thickness of the fins, and you had to solve for areas of fins and non-fins. Then you had to use the length of the critical lengths, which involved the thickness again of the fins, and then you were able to find another area. Then you were able to plug it into this equation. I forget the exact loop name of this, but then you plug it into using your critical length, and in order to get this number, and this number, this number it gives you a variable so you're able to see what's happening further along down the road. But then you use your critical radius over your regular radius to get yourself an efficiency from the table, and then you're able to plug it in to find your temperature, and then this temperature will in turn give you back to your regular heat transfer value, and you'll get your wattage on the outset. The second problem had to do with finding heat transfer for all different types of fins. So for this first example, it was an infinitely long fin. So you plug and chug into these equations, and as you can see, we had an infinitely long fin, an adiabatic fin tip, a fin tip with a temperature at 250, and a convection from the fin tip. But what all these equations have in common is these first two terms. So the only difference is, depending on where you're at, adiabatic, you use tan H. At a specific temperature, you use this relationship, and at convection, you use this relationship. And these equations give you all different values based on what you're looking at and solving for. And then when you graph it, you're able to see the difference. So infinitely long fin loses temperature a lot faster than any other of the three values, which are all pretty close to each other. The final one had to do with resistance in order to find specified temperatures. So, like for example, in this one, we had different resistances. So we had to solve the resistance of the board, resistance of convection, and then you add those up together, and you're able to get R total, which gives you your T1. And then in order to get T2 at the board, you have to go back to use R at the board, get T2, which ends up still being very close. Then, for the second part of the problem, we had to deal with efficiency of the fin, and then we were able to get area of unfinned and area of the fin. And obviously the area of the fin is larger. And then you're able to use T base with this equation using the efficiency we found in order to solve out and find the first temperature. And then you have to use, once again, resistances in conduction for L over Ka in order to get this equation down here. So this is basically R total, but of a different value. And then you're able to get 39.8 and 39.6, which once again are very close to each other. The only points of confusion in this part would be these equations and just really specifying which one to use where.